BSc Chemistry, Organic Chemistry, SEC second chapter Fuel Chemistry, presented by B. Madhav Narayan. Petrochemistry. Petrochemistry is one of the parts of fuel chemistry in which you learn cracking of petroleum. The contents of cracking of petroleum are 1. Cracking, classification of cracking, thermal cracking, liquid phase thermal cracking, and vapor phase cracking. First one, cracking. Cracking is a method in which heavy oil or mid oil containing long chain hydrocarbons are fission into lower chain hydrocarbons in absence of air. Crude oil contains many large molecules. If these are to be used as fuels or feedstock for the chemical industry, then they have to be cracked into smaller molecules. When hydrocarbons burn, they are reacting with oxygen in the air. In general, the smaller the molecule, the better it will mix it than react with air. The picture gives you a brief idea about percentage of various components: fuel gas, naphtha, diesel, petrol, kerosene, fuel oil, and bitumen. Cracking. When cracking process is carried out, some chemical change takes place. The chemical change involves breaking of carbon to carbon single bonds in alkanes. It converts heavy fractions into higher value products. Experimental investigation has shown that thermal cracking proceeds via free radical mechanism, whereas catalytic cracking proceeds via carbocation carboniamine mechanism. Importance of cracking and definition of cracking. What is the importance of cracking? The purpose of cracking is to meet the demand for gasoline as a result of rapid rise in automobiles. Second one, production of gasoline from less volatile products of petroleum, that is heavy oil and kerosene oil, by means of controlled pyrolysis or cracking. Let us study what is cracking. Cracking is the decomposition of higher hydrocarbons into lower hydrocarbons of lower molecular weight. That is, heavy molecular weight, higher hydrocarbons are converted or changed or cracked into lower molecular weight. Take for example decane. Decane contains 10 carbon atoms and 22 hydrogen atoms. It's a long saturated hydrocarbon. When this is cracked, two components are obtained. One is N-pentene, molecular formula C5H12, and pentene, molecular formula C5H10. Classification of cracking. Before classification, I explain the importance of cracking. Gasoline from cracking has far better characteristics. Petrol from cracking contributes about half of the total petrol used. There are two methods of cracking in use. One, thermal cracking. Second one is catalytic cracking. First one, thermal cracking. This involves heating alkanes to a high temperature 700 to 1200 Kelvin and putting them under high pressure up to 7000 kilopascals. That is, in thermal cracking, the term involves heat. That means cracking is carried out at a very high temperature. The temperature is 700 to 1200 Kelvin along with high pressure of 7000 kilopascals. Such high amounts of energy are required to break carbon-carbon bonds. These bonds break in a way that one electron from the pair in the covalent bond goes to the end carbon atom in each chain. One of the chain pulls the hydrogen of the other. Consequently, one of the chains needs to be double bonded to fulfill the necessary amount of bonds. This is how the alkenes are formed. Example, a long chain hydrocarbon where R and R represent the chain is continued from both sides. On thermal cracking gives free radicals. These free radicals then gives a lower molecular weight hydrocarbon chain and an alkene. Thermal cracking, in which two processes are involved. One is liquid phase thermal cracking, second one vapor phase thermal cracking. In liquid phase thermal cracking, the temperature is maintained at 475 to 530 degrees centigrade or 748 to 803 Kelvin in SI unit. Pressure is about 100 kilograms per square centimeter. When thermal cracking is carried out in liquid phase, the yield obtained is found to be 50 to 60%. The octane rating is about 65 to 70. Second one, vapor phase thermal cracking. Here the cracking oil is first vaporized and then cracked. Temperature maintained is 600 to 800 degree centigrade or 873 to 1073 Kelvin. Pressure is maintained 10 to 20 kilograms per square centimeter. In thermal cracking with vapor phase, high temperature is required than liquid phase thermal cracking because the heavy oil or middle oil is to be vaporized first, then vapor phase heavy oil or middle oil is to be subjected to cracking. Therefore, vapor phase thermal cracking needs high temperature. When the lower molecular weight hydrocarbons are obtained from vapor phase thermal cracking, the compounds obtained has better anti-knock properties. Finally, catalytic cracking. The term itself indicates the cracking process is carried out in presence of suitable catalyst. Catalytic cracking breaks complex hydrocarbons into simpler molecules in order to increase the quality and quantity of lighter, more desirable products and decrease the amount of residuals. This process rearranges the molecular structure of hydrocarbons compounds to convert heavy hydrocarbon feedback into higher fractions to lighter fractions such as kerosene, gasoline, LPG, heating oil and petrochemical feedstock. Catalytic cracking is similar to thermal cracking except that catalysis facilitate the conversion of heavier molecules into lighter products. The use of catalyst in the cracking reaction increases the yield of improved quality products under much less severe operating conditions than in thermal cracking. The typical temperatures are from 850 degree to 950 degree Fahrenheit at much lower pressure 10 to 20 psi. The catalysts used in refinery cracking units are typically solid materials, zeolite, aluminum hydrosilicate treated in bentonite clay, fuller's earth, bauxite and silica alumina that come in the form of powders, beds, pellets or shaped materials called exudates. There are three basic functions in the catalytic cracking process involved. The first one, reaction. Feedstock reacts with catalyst and cracks into different hydrocarbons. The second stage, regeneration. Catalyst is reactivated by burning of coke. And stage 3, fractionation. Cracked hydrocarbon stream is separated into various products. For more information, you can refer P.C. Jain and M. Jain, The Engineering Chemistry, Dhanpat Rai Publishing Company, New Delhi. Second one, B.K. Sharma and Gaur, H. Industrial Chemistry, Goel Publishing House, Meerut. Or also refer sciencedirect.com.